space fans, and welcome back to Singularity, your channel hooking you up with everything from afterburning jet fighters and continent-crossing rockets right up to the edge of the universe itself. I'm your host, piloting this virtual spaceship, ready to take you on another mind-expanding journey. Today, we're exploring our very own cosmic backyard, the solar system. Strap in, because this familiar place is packed with more extremes, bizarre facts, and downright funny quirks than you probably realize. Let's launch! First off, just how big is this neighborhood? We talk about planets, sure, but the sun's reach? Its exclusive gravity area, the zone where Sol is definitively the boss? Forget city blocks, think bigger, way bigger. We use light years for this stuff. A light year is the distance light zips through in one Earth year. That's a staggering 6 trillion miles or 9 trillion kilometers. It's a number so big your brain just kinda gives up. Well, our sun's gravitational kingdom extends out about one whole light year, translating to roughly 63,000 astronomical units. That's right, the sun is gravitationally hugging objects that take light a year to reach. Now that's long-distance influence. Getting around this vastness? Yeah, that takes time. Serious time. Our fastest man-made object, NASA's Parker Solar Probe, is currently setting speed records as it dives daringly close to the sun, but even at those incredible velocities, traversing interstellar distances would take centuries, even millennia. So for today's grand tour, thank goodness for the warp drive of video editing. Let's start near the central furnace, Mercury. This little scorched speed demon orbits at a mere 0.4 AU on average. Being so close, it completes a blistering year in just 88 Earth days. Imagine celebrating your birthday every 3 months. But don't expect long days to plan the party. One single rotation, a Mercury day, takes a leisurely 59 Earth days. This sluggish spin is thanks to the sun's immense gravity playing tidal tug-of-war, locking it into a 3-2 spin-orbit resonance. Mercury is tiny, just 5.5% of Earth's mass, but it's incredibly dense, packing a massive metallic iron core that makes up about 85% of its radius. It's less a planet, more a giant metal ball bearing with a rocky crust. Next door, we find Venus, simmering away at 0.7 AU. Often called Earth's twin due to its similar size of 80% Earth mass and surface gravity of 90%, the resemblance ends there. This twin took a terrifyingly wrong turn. It's the hottest planet in the solar system. A uniform, lead-melting 465 degrees Celsius, thanks to a runaway greenhouse effect, trapping heat under thick clouds of sulfuric acid. The atmospheric pressure is absolutely crushing, over 90 times Earth's, equivalent to being a kilometer deep in our ocean. Venus also spins backwards, retrograde, and does so agonizingly slowly. One Venusian day drags on for 243 Earth days, which is somehow longer than its year of 225 Earth days. 6. Your birthday would literally happen before the day was done. It lacks a protective global magnetic field and is smothered in volcanoes. Tens of thousands, potentially over 85,000, making it the most volcanically active planet we know. Its closest approach brings it to 38 million kilometers from Earth, our nearest planetary neighbor, but definitely not one you'd want to visit without a very, very good heat shield and pressure suit. Okay, let's head towards friendlier territory, our very own moon. Tidally locked, it perpetually shows us the same familiar face, forever hiding its far side. It's small, just one of Earth's mass, but its value is skyrocketing. Why? Resources, baby. We're talking crucial rare metals for our technology, and potentially enormous deposits of helium-3. This isotope, rare on Earth, is abundant on the lunar surface thanks to the solar wind, and could be a revolutionary fuel for future fusion reactors. Potential value estimates run as high as $3 billion per ton. Then there's water ice, potentially billions of tons of it, hiding in permanently shadowed craters at the South Pole. This isn't just for drinking. Crack it into hydrogen and oxygen, and you have rocket fuel and breathable air right there on the moon. This transforms the moon, particularly that strategic South Pole, into a vital staging post, a potential transportation hub for the entire solar system. Launching heavy rockets from the moon's lower gravity takes far less energy than blasting off from Earth. The economic potential runs into the trillions of dollars, leading to inevitable future tension among nations vying for access. Add to that natural shelters in the form of ancient lunar caves offering protection from radiation, and you see why the moon is suddenly very hot property. Fourth rock from the sun, Mars. Orbiting at 1.5 AU, It's the red planet, smaller than Earth, 11% Earth mass with significantly lower gravity of 38%. But living there would be tough. The atmosphere is incredibly thin, less than 1% of Earth's, mostly CO2. It lacks a global magnetic field shield against radiation, gets much weaker sunlight, and is generally very cold. Still, Mars fascinates us. It boasts Olympus Mons, a shield volcano the size of Arizona, and the tallest mountain on any planet in the solar system. Evidence suggests Mars might have had liquid water in its past, fueling hopes of finding ancient life. And of course, it's the primary target for Elon Musk's vision of establishing a self-sustaining human settlement beyond Earth. A challenging dream, but perhaps humanity's next great adventure. Beyond Mars lies the Asteroid Belt, a vast ring of debris orbiting between 2 and 3 AU. This isn't a densely packed minefield. The asteroids are typically millions of kilometers apart. These are the remnants of a planet that never formed, thanks to Jupiter's immense gravitational meddling. The belt contains millions of asteroids, from pebbles to giants like the dwarf planet Ceres, which holds about a third of the belt's total mass. Even so, the entire belt's mass is only about 4% of our moon's mass, mostly empty space. But some asteroids are treasure troves of valuable minerals and rare metals. The most famous is 16 Psyche, thought to be the exposed nickel-iron core of a protoplanet, potentially worth an eye-watering $10,000 quadrillion. NASA has a mission en route to investigate right now. Now, prepare for the system's undisputed heavyweight champion, Jupiter, holding court at 5 AU. This gas giant is simply colossal, 318 times Earth's mass, containing over 2.5 times the mass of all the other planets, moons, and asteroids combined. Despite its bulk, it spins incredibly fast, completing a day in just under 10 hours. Jupiter is a swirling chaos of storms, the most famous being the Great Red Spot, an enormous anticyclone wider than Earth that has been raging for at least 190 years, perhaps tracing its origins back 350 years. Jupiter radiates more heat from its interior than it receives from the sun, fueling its wild weather. Its powerful magnetic field creates intense radiation belts, deadly to unprotected life. Jupiter commands a veritable solar system of moons, 95 confirmed ones. 14. The stars of this show are the Galilean moons, especially Europa and Ganymede, the largest moon in the solar system. Both are strongly suspected to harbor vast globe-spanning oceans of salty liquid water beneath their icy shells, making them prime candidates in the search for extraterrestrial life. Jupiter also acts as a crucial protector, its gravity serving as a cosmic vacuum cleaner, deflecting or capturing potentially hazardous comets and asteroids. 16. Further out, we encounter the breathtaking Saturn at 9.5 AU. Famed for its magnificent rings, Saturn is another gas giant of 95 Earth masses, but is remarkably light for its size. Its overall density is less than water. It also spins rapidly, a day lasting just 11 hours. Those iconic rings are composed mostly of countless particles of water ice, from dust specks to mountain-sized chunks. They span 280,000 kilometers across but are unbelievably thin, mostly just tens of meters. Wider than the Earth-Moon distance, they are a truly huge yet delicate structure. Enjoy the view while it lasts, though. The rings are raining down onto Saturn and are expected to disappear within roughly 100 million years. Saturn currently holds the title for most moons, with 146 officially recognized. Its largest moon, Titan, is unique, featuring a thick nitrogen atmosphere, Earth-like landscapes carved by liquid methane, including rivers, lakes, and seas. Saturn also boasts a bizarre hexagon storm at its north pole, and conditions deep inside might allow for diamond rain, theoretically worth quadrillions. Now entering the ice giant realm. First, Uranus at 19 AU. This planet is tilted completely on its side 98 degrees, likely due to an ancient collision, causing extreme, decades-long seasons as it rolls around the sun. It's the coldest planet, an ice giant plummeting to minus 224 degrees Celsius. Its atmosphere, mostly hydrogen and helium with methane giving it a pale blue hue, also contains hydrogen sulfide, meaning it probably smells like farts. Nice. Our final planetary destination is Neptune, the furthest official planet at 30 AU. This deep blue ice giant of 17 Earth masses gets its color from atmospheric methane absorbing red light. A Neptunian year takes 165 Earth years. It's home to the strongest winds in the solar system, exceeding supersonic 2,000 kilometers per h. Beyond Neptune lies the domain of the dwarf planets. 244 Pluto. It was the ninth planet until 2006 when the definition changed after astronomers found Eris and other objects of similar size in its neighborhood. Planets now must have cleared their orbital neighborhood, which Pluto hasn't, so it became the poster child for dwarf planets. Pluto inhabits the Kuiper Belt, a vast disk of icy bodies, dust, and comets extending from Neptune's orbit out to around 55 AU. This region is populated by potentially trillions of objects, including other dwarf planets like Eris, Haumea, and Makemake, frozen relics from the solar system's birth. 28. But the sun's influence extends even further. The solar wind, a stream of charged particles, inflates a protective bubble called the heliosphere. Its outer boundary, the heliopause, where the solar wind stalls against interstellar gas, lies around 120 AU. It takes the solar wind roughly a year to travel this far. It takes 16.5 hours for sunlight to reach the heliopause. After the heliopause, you're technically in interstellar space, but you're still deep within the sun's gravitational grasp. Stretching incredibly far, from about 2,000 AU out to 100,000 AU or more, lies the vast, spherical Oort Cloud. Sunlight takes about 11 days just to reach the beginning of Oort Cloud, and to reach the outer edge, you're looking at a journey of 1.6 years. This is a hypothesized reservoir of trillions of icy bodies, the ultimate remnants of the old sun's formation, kicked out long ago. It's the source of long-period comets. Now, under the definition we're using today, the term heliosphere also describes the immense bubble defined by the sun's dominant gravitational influence, extending out to that 1 light-year mark. This enormous gravity sphere sits right in the middle of the Oort cloud, defining the true boundary of our solar system's gravitational empire. Comets, those beautiful icy visitors, originate from both the Kuiper Belt and this incredibly distant Oort cloud. And that's our whirlwind tour of the solar system. From the sun's fiery breath to the absolute frozen edge of its gravitational reach, it's a place of incredible diversity, mind-bending scale, and constant surprises. What fact surprised you the most today? Where should Singularity point its telescopes next? Let me know your thoughts and suggestions down in the comments. If you enjoyed this cosmic journey, please give this video a thumbs up, subscribe to Singularity for more awesome content, and definitely hit that notification bell so you don't miss our future explorations. Thanks for joining the crew today, space fans. Keep exploring, keep looking up, and I'll see you in the next video.